Good day, folks. Welcome to my YouTube channel. This is the Eastern Cape 2024 trial exam. I'm going to look at the chemical equilibrium. Consider the following hypothetical reaction at equilibrium. This is a hypothetical reaction. Hypothetical means it's a reaction that doesn't exist. These are the compounds or elements that do not exist. The data in the table shows equilibrium concentrations of A and B at different temperature. Do you see the reactant and the product? Right. So guys, if you look at the temperature 200 degrees Celsius, the concentration of reactant is that and the concentration of product is that. If you compare between the two, the concentration of product in the first equilibrium, the concentration of product is higher than the concentration of reactant. That means it's the forward that is favored, right? Now if you look at the temperature increase, when the temperature increases from 200 to 300, you know that it favors the endothermic reaction. That favors endothermic reaction. But now, in the new equilibrium, the equilibrium was disturbed by increasing the temperature there. But if you look at the disturbance now, look at the concentration of the product. It has increased. The reactant, sorry, which is the reactant is A. The concentration of the reactant, it has increased. But look at the concentration of the product. It has what? Decreased, right? So here, reverse is what? Is favored. Reverse is favored in the new equilibrium. Keep that in mind. It's very important. Now, I'm going to skip the definition of Le Chatelier's principle. 6.1.2, it says, if the forward reaction is the forward reaction is the forward or reverse reaction favored at 200, right? So at 200, forward is favored. So the answer is what? Is forward. Forward is favored. And then forward reaction is favored. And then it says give reason for your answer. Your reason for your answer, the concentration, what you can say there, the concentration of B is higher. If you look at the concentration of B is higher than the concentration of A. So you can say the concentration of B is higher than the concentration of what? Of A. The product is greater than the concentration of the reactant there. Now it says how will the equilibrium concentration of A at 200 be affected by the following? Choose increase or no effect or decrease. If we increase the pressure, here, how will affect the concentration of A? So if we increase the pressure, the increase in pressure favors the side with the least number of moles, which is the reverse. Reverse will be favored. This is the side with the least number of moles. So if this is the side that is favored, the concentration of that will increase. So the answer there is what? Is increases. Right? Addition of catalyst, no effect. When we add catalyst, there's no effect at equilibrium because that's not one of the factors that affects the chemical equilibrium. Now it says, is the forward reaction exothermic or endothermic? Right? Which is, as we can see here, the reverse is favored, which is when the reverse is favored, when we increase the temperature, that means is the endo. Then the forward is going to be what? The exo. Right? It's going to be the exo. Right? 6.1.6, it says, use the Le Chatelier's principle to refer to the data and explain this, explaining this exo and endo. So how I explain that, it's based on the increase of temperature, right? What we do here, there's an increase in temperature. Increase in temperature favors endothermic reaction. That's 1 mark. And then we have 3 marks there. So there, another thing we can say reverse reaction is favored. How do we know the reaction is favored? It's because when the temperature increases, the concentration of reactants increases and the concentration of product decreases from that value. It has increased from that value to this value, and from this value the product, it has decreased. So reverse reaction is favored. Right? And then what we can say the concentration of the reactant, which is A, increases. Or we can say the concentration of the product decreases when the reverse is favored, right? Now in 6.2 it says initially 1.05 mole of bromine are sealed in an empty container. We're not told the volume of the container. It says the following reaction occurs at 1600 degrees Celsius. So we have a bromine gas. It produces the bromine in a gaseous state. So it says at equilibrium the concentration of bromine gas is 2.074 mole per dm3. That's the concentration at equilibrium. And then it says the equilibrium constant is 6.34 times 10 to the power negative 4 at 1600 degrees Celsius. Now it says calculated the volume of the container when they wanted the volume of the container. So what we can do here, we're going to make use of the table and the KC. So let's insert what we have here. So we have a 1.05 mole for what? For bromine gas. That's the initial 1.05. And then the bromine, we have nothing there, right? And we were told the concentration at equilibrium, the concentration of the bromine gas is that, right? The concentration of the bromine gas, so we're going to put it there. It's 2.074. That's 2.074. That's all we have for now. So what we're going to do, we're going to make use of Kc and the concentration that we have. So we're going to say Kc is equal to the concentration of product. The product is what? Is Br. So it's going to be concentration of Br to the power 2 divided by the bromine gas, right, to the power 1. And then our Kc there at 6.34. 6.34 times 10 to the power negative 4 equal to, and then we substitute this concentration is a concentration of Br2. So the concentration of Br2, it's this one, it's 2.074, right? And then we do not have that concentration of Br, which is the product, and then we cross multiply. We're going to have Br to the power 2 and then these two. So it's going to be 6.34 times 10 to the power negative 4 times 2.074. And then we put the square root. So the concentration of Br is 0.003, right? 0.03 626 mole per dm3, right? So this concentration is a concentration of Br, which is the Br there. It's going to be 0.03626, right? So we know normally in the product what we do, we say the initial plus what has been produced in the product and gives us that. So clearly this amount is going to be there. This is the concentration right? This is the concentration. So but now this concentration, we have to change it into number of moles. So when we change it to number of moles, we multiply by volume. The volume we do not have in this case is the one that we're looking for. We're going to times it by V. So we times it by V, and we know what we do. We say to the initial plus the product formed is going to be that. So same amount that is going to be here is going to be there. It's going to be 0.03626 V, right? And then here we're going to do a mole ratio here. So the ratio here, it's 2:1, right? So this amount is going to be a half of that. So a half of that is 0.01813 V. It has a V. Don't forget the V. It's very important. So what we do here, we normally say the initial minus the amount used it gives us that, right? But in this case now, we, in order to get this amount, we need to say this minus this. It's going to give us that amount. Or we have a volume here. We have a this is the concentration, right? We change this into a number of moles. So it's going to be the same. We're going to times this by the volume, and it gives us that. So it's going to be 2.074 V, right? So remember what we are looking for. We are looking for V. So what is going to help us to get the V? We're going to say this minus this give us the V. So the unknown here is going to be only V. So we're going to get the answer. So it's going to be 1.05 minus 0.01813 V is equal to 2.074 V. And then if we do the math there, our V is going to be 0.5 dm3. That's the answer there.